Okay. So the problem statement here is that line AB 60 millimeter long. It's a true length. Inclination 30 degree with HP. So we denote it with the letter theta. Inclination with vertical plane 45 degree. We say it's a phi. End point A 20 millimeter above HP, 30 millimeter in front of PP. Okay. So we'll start with the solution. As we see the few basic cases here. So we have to start with the XY line itself. Okay. First, you have to get the XY line. And even we had discussion that none of the view will be equivalent to true length. Means the final front event of view will not be of true length. Okay. It will be definitely less than the true length. Okay. So first of all, get the XY line. Draw one line. Say XY line. Okay. You can name this line as a XY line. We say it's a X and Y line. Okay. XY line. Ready? Then, as we have taken the cases earlier also, okay. So from X itself, you take any one line that will be perpendicular to this line. Okay. So this line is ready. Another line. Okay. Then you have this much data with you. Okay. So you have to think, can you take 60 millimeter as a first data? No, we can't take it. Even 30 degree, 35 degree, 45 degree, no. But endpoint A we can mark easily. So from here at 20 millimeter above HP, we'll take 20. So this will be the point above. Then 30 millimeter in front of VP, it is given. So we'll take 30 millimeter. Okay. So I will name this point as a point A dash and point E, right? So we'll name it as a dash and A point. And then immediately you have to draw a line parallel to XY line passing through point A, get line. Similarly, line parallel to XY line through point EA. Okay, get line. Then immediately next, you will be taking once this is over, then you can take the inclinations. Okay, so I will be giving the dimensions here. This distance is 20. This distance is 30. So 20 above HP, 30 millimeter in front of VP, right? Then through point, as the line is given inclined 30 degree to HP, 45 degree to VP. So what we are going to do here, we will be taking the angle 30 degree and 45 degree to concern point. Okay. So what we should do here, set the projector, adjust it with this, align with this line, and get 30 degree with HP, then 45 degree with VP, 45 degree with VP. Okay, then get a line, get thin line first, okay, get line, this angle is 30 degree, this one 45 degree, we denote this third as an angle theta, this angle is phi. Okay, so I'm just writing this for your information. Okay, so you should not get confused that what is meant by theta, what is meant by phi. It's the standard notations you will find in every study material, every book. These kind of notations for angles have been used. Okay, now you are knowing about the length of line. True length is given to you. This true length of 60 millimeter, it is known to you. So what you will do, we'll take length now. Okay, we'll take length that is given 60 millimeter. So either you can take this distance 60 in rounder, or you can have a measurement directly from by using the scale. Okay, so whatever it is convenient to you, do one thing, take 60 millimeter, 60. So this is what the 60 here. You will get the point for 60 and make this line thick. Make this line thick one. Okay. Then again the 60 true length remains same whether it is a front view or the top view. 60. So make this line dark, thick. Okay. And for sake of convenience, and as this is the first problem, what I will do, I will erase the extension. So there will not be any confusion at all. Okay, I will erase this. Now it is just 60 length. This is a TL 60. This TL is also in top with this 60. Right? Now this is the point. Suppose B dash. Okay. But actually this is not B dash, and even this is not point B. But just now I will name it. Okay. See, you have discussed the cases if the line is inclined to one plane and parallel to another plane, and you know the procedure. What procedure we have followed? Okay. So what we'll do now? This is what we can get with reference to the given data, right? Now we have to follow certain steps so that you will get the final front view and the top view. And as you know that final front view and top view, it will be less in length as compared to true length. Okay. So then what you will do to this projector or end projector line for A or perpendicular to XY line, do one thing, draw a line passing through B dash. Okay. Get it this line to the locus of A. Okay. Till locus, you continue with that line. Where it touches with the projection drawn through A, I will be specifically showing with the arrow. Okay. So from here, we move down to this line. Okay. And then for your just understanding, I will be going to. So You just recall to your basic things which you have learned. If this will be the true length and consider the line inclined to HP suppose and parallel to VP, then this will be the front view and this becomes your top view, or we can say the plan, right? So the length from this A to this point by taking the projection, suppose if I even here I will name this point as a B. Okay. Notation I will change, modify it accordingly. Okay. Then this AB is nothing but your plan length. You did it in our previous lecture. You did it. This length is your plan length. How much you will get? We'll take that measurement later on. Okay. So we can have a measurement also. So in my case, how much I am getting? Let me check. This I am getting 52, right? So 52 is my PL. So this I am getting 52. Okay. PL. Similarly, do one thing. Through this endpoint B of your true length, just repeat the procedure for line inclined to VP. Go further up till you will be touching to the A dash. Starting from this, going upward till it touching to the, and it will give the, suppose if I say point again B, but this distance is nothing but distance of your front view, and we can say simply front view or EL. Earlier we came across this when the line inclined, discuss which line inclined to one plane parallel to another plane. Okay, so this is nothing but your EL or front view length, and how much I am getting here? I will check it. This length which I am getting here is 42 something or 43. Yeah, 43. EL is now 43, right? Okay. So from here we have taken this. Next step, so this for this true length in front view, that is line inclined to HP, you are getting a top view and that AB here, okay, and the distance from A to B is nothing but your top view length, or alternately we can say it's a plan length, and in short we'll write as a PL. Okay, so this case you did it when we have taken the problem line inclined to one plane only. Okay, so for this front view, this is top view. Now for this top view, this is going to be the front view, means for this true length top view, uh, true length front view will be the line parallel to xy line, or it is nothing but the front view length, or alternately we say it's a elevation length, and in short it is written as a EL, right? Got it? Now the next step, now the next step is very very important. Remember, okay, you will be doing the things one by one. So here set this roll and draw roller scale with the xy line, take it further, and through B dash whatever we have already received here, okay, through that I will be drawing one more line. Okay, and this is nothing but It's a separate line. Doesn't mean that you will be touching with here or not. And this line is nothing but locus of B, locus of point B. Similarly, you should take the locus of point B through this point in top view as well. So this line is nothing but locus of B. Okay, you get this line, and then I hope that you did it, getting two lines through these 2 points, 16 points. That is quite simple. Now the next, you take a rounder, keep ready your rounder, or you cancel the compass. Okay. Now this is the elevation length, means this is your front view length. But front view, as the line is inclined to both the plane, so front view can't be the line parallel to XY line. No, it is not possible. So take a length in compass equal to this EL. Hello. Keep your rounder, take your this length in your rounder. Okay. I hope you're ready with that. Now the next, you will be drawing the arc. Compass is at A dash metal end and taking this distance. Okay, taking this EL in compass and drawing arc, drawing a arc, and wherever it cuts to the locus of B is going to give the point. This is going to be give the point. Say suppose again I say it's a B. Okay, I will write it as a B point. Okay, so notation we need to change further, but I'm just writing here. Okay, now this is the arc of distance EL, keeping metal end at A dash and drawing arc, the direction of arrow, this one, okay, from B to this B. Okay, then join A dash with this one, and this is going to be your final front view. This will be your final front view. Okay. The next, now we have covered with this EL. Now take a distance in compass equal to PL. Distance equal to PL. I hope you completed previous step. Now you will be taking A to B in, that is a plan length in compass, and you will be drawing the arc till it cuts the locus of B. Till it cuts the locus of B, suppose. Okay. Now this is the point where it cuts, and this is the arrow direction of arc. Okay, this is the arc, and now this point you have to join right. Okay, and this will give you another angle. So here this theta, but final front view, this is going to give the another angle, and we can name this angle as this angle. We say it's alpha. Then similarly, new angle which we are getting here, we say it's a beta, alpha and beta. Okay. Similarly, we'll change the notation. See, A dash and A, no problem. But here, this A and this is going to be the point B. We say A dash, B. We say it's a B2. We say it's a B2 point. Say B2, while taking, when we take the projections upward, we say it's a B2 dash, B2 dash. This is the point B dash, but B dash actually will be this point. So instead of keeping this B dash, we say B1 dash. Okay, we say B1 dash. Now the corresponding point in PL here, we say it's a B1 point. So B1 to B1 B dash, B2 to B2 dash, and your final front view is A dash B dash. This is the front view. Front view. This is going to be the top view. Okay. This line AB is your top view, angle beta. This is the A dash B dash, your front view, angle alpha. Okay. This is the elevation length, EL, plan length, and one more important point we have to add here. A dash A is the one projector. Similarly, you have another point B to B dash. Suppose if I draw a common line and through this, okay. Suppose if I draw line, common line through B to B dash, and if I suppose take this line further, okay. The distance between projector, this is nothing but the projector. Projector for A, projector of A, and this is nothing but the projector of B. Okay, projector of A and projector of B. And the distance between these two projector is called as end projector distance. This distance, this is going to give the one more term. The distance, this one, okay, this is called as a end projector distance. I will write here end projector EPD, end projector distance. Okay, EPD is nothing but the end projector, projector A, projector B. The distance between two projectors is nothing but the end projector distance. Okay, so here suppose even in given data here, final answer you will come to this EPD is nothing but the end projector distance, end projector distance. Okay, now end projector distance, and you can have a measurement of that also, how much end projector distance you are getting. Accordingly, you can have measurement of this angle also. Then EL, PL. So how much EL and PL we got here? EL we got 43. Once you will get completed this one, plan PL is 52. End projector distance, I can measure it. End projector distance. This is, I'm getting 30. So I will write end projector distance as 30. alpha and beta, that angle I can measure with by using this one. Okay, so how much I am getting it, but you can use the uh, very accurate and precise protector here. So, and what am I getting, like 55 something, maybe in actual at your end, how much you are getting, just measure it. Maybe 50, 47 something you will get. So here the beta might be, suppose 50 or something, maybe 50, 52. Suppose if I, this is suppose 48 or something. Okay, maybe because I have previous value, then I can give the uh, measurement. This is in millimeter. Remember, this plan is in millimeter. Okay, so this is going to give the complete solution in terms of all these details. Okay, these all the terms you're supposed to keep in mind. Okay, and treat this as a model question and answer. With reference to that, you're supposed to be in position to solve any sort of problem. So this is the problem number 2 on projection of line. Problem statement: a line AB, 60 millimeter long, is inclined at an angle of 30 degree to horizontal plane. Its elevation length is 40 millimeter. Draw the projection of line AB when end point A is on VP and 10 millimeter above HP. This A point is on VP. If I consider this as a vertical plane, okay, you try to understand. This is a vertical plane, and this point A is on VP, means it is not on HP, but it is on VP. From base, it is 20 millimeter, sorry, 10 millimeter above HP, but it is on VP. Okay, right? So your point A in top view will be on XY line, and the front view A dash point will be 10 millimeter above HP. Okay, try to understand with this. See, this is the vertical plane and horizontal plane, and with reference to that, try to understand this is the XY line. Okay, and this point is given on VP, but where it is on VP, it is 10 millimeter, just 10 millimeter above HP. Okay, right. So A dash will be above HP by 10 millimeter, above XY line 10 millimeter, but point EA means the point reference point of your top view, that will go on EXY line. Okay, so we'll start with the solution step by step. Draw XY line. First, get the line. Keep sufficient space below and above XY line so that there will not be interruption or repetition for solution. Okay, draw XY line. You name that line as XY line. Immediately you have to name it. Then, as usual, the thing which you are done in previous case, draw a line which will be perpendicular to XY line. Then get the points first. So it is 10 millimeter given above HP and it is on VP. Okay. So See systematically in even given data, this point and circle I have mentioned, it is on VP. Okay. This will not, these things you will not get in any of the book. Okay. And this arrow above HP means arrow in upward direction. In front of VP, the previous case we have seen, that is arrow in downward direction. Okay. So this is the point. We can name this point as a dash, and the top view point you are going to get on XY line itself, because this point is on VP. Okay, right? Endpoint is on VP. Then immediately next, through A, draw a line parallel to XY line. Through A, already it is on XY line, so that line is present here. Okay, means this data we have consumed. Okay, now this is over. Next, what you can do here? Can you take 30 degree? Yes, you can take 30 degree through point A. So what we can do here? We can draw line 30 degree through this. So first of all, with the projector, mark 30 degree. Get the line. Even the length of line is known to you. So that length is 60. So without wasting time, I will take directly 60 only. This 30, I say 60. This point will be the this angle will be the angle 30 degree. We denote this angle with HP with symbol theta. As you know, as you did in a first problem, this point is going to be the B1 dash point, not B dash, B1 dash. Now we will give the notations accordingly. Okay. Now this one, so question mark here. So this data also we have used. Even this 60 millimeter length TL, we have used this here. Now EL, you know that the EL will be always on the locus of A dash. Whether it is AB line, then A dash, EL. So we'll take EL. How much EL given? It is given 40 millimeter. So I will be taking 40 millimeter here. See, I will make it bit dark. This 40. Okay. I will write here as a EL. This is given EL 40 millimeter. EL 40. Right? EL 40. See, now we have also consumed this one. Okay. Now, with reference to given data, this much information or this much diagram we are able to complete. But can you finish it, get the full answer with reference to this? You can say yes. Okay, we can get it, right? See, then you do one thing. As did in a previous problem, you must have to draw the locus passing through this B point. Okay, so this is the locus of, now I will say locus of EL of B, locus of B, right? Then you know that the EL distance can be drawn, rotated by using R. Okay, then you will get the B1 dash point. This is the point distance you will be taking in compass. Keep ready with this distance. Take this distance EL uh, distance in compass. Okay, and draw a arc where it cuts to B dash. Draw a arc. It will cut to B dash somewhere a locus. This will give the point. This is going to give the point, and we can name this point as a B dash, right? Then finally, join A dash with B dash, A dash with B dash, and this is nothing but your final front view. I will write as a front view, or you can, even though you can write as a elevation. Okay, this elevation is nothing but the front view length or elevation length, right? Okay. Now you might be understanding what things very comfortably, that what exactly and how we'll get the point B now. Okay. So for that, the next step is, as you know, through this point, you can draw a line passing through straight way down B1 dash till it touches to the locus. Reference line passing through A. You did it in your first problem. Similarly, okay, and this will give the point B1. Taking projection from B1 dash and obtain this B1. Okay, if I give the measurement here, what will be the distance? Hello, A to B1. What do we say to this distance? EL, PL, whatever. Anyone, please respond.
PL. Oh, PL.
It's a PL, right? So I will be specifically writing here this PL you got, right? This is the thing. Then see, you know that B1 dash, B dash and B point supposed to be on single projector, right? We did it in last problem. See, A dash and A on single projector, this one. So B dash and B point will be on the same projector, right? Now PL is with you. What you can do then? Hello, anyone? Let me know how we'll get this point B here. Can we take PL in compass? Hello? Can we take PL in compass and rotate it? Yes or no?
Yes, sir. Yes, sir.
Yes. Now, if it cuts to this second B projector passing through point B dash, where it cuts, can we name that point as a B point? Yes. This point. What we should name? B dash or B2? Yes. Yes. Please. This point will be the point
B2.
B, not B2. B point. A dash and A on one projector, then B dash and only B, right? So this will be the point B. Okay. If you join it, B with A, it is going to give you the top view. Okay. So as this is the second problem. Okay. Not to worry. Little confusion might be possible, but at least after this problem, you will get each and everything as per as the concept of projection of line inclined to both the plane is concerned. Okay. Then next, draw a line as a locus passing through point B. See, this is the locus of B, which I am drawing here. Locus of B in top view. Then you know the true length. So otherwise, do one thing and you just confirm whether your answer is correct or not. See, EL, you can project it. If you project it further, so this is the arrow which you are taking it from here. Alternately, here you don't have limitations. Two ways you have to get this point P2. Okay. Okay. You just ensure that whether you are getting the exact answer or not. Little error, it's quite obvious and it is acceptable. See, if I take the keep the composite A, see, I am getting the same point exactly, right? I am getting the point. Understood? If I take the measurement in compass 60 millimeter, okay, without even I have not taken it at this point, I got it by taking the projections from here, but still it is going to give the exact answer, right? Then join this B2 with this point, right? See, now you got this B2 point. Now this angle, what will be this angle? Hello? Symbol? Phi, beta,
Beta.
phi or beta? Yes. Angle is phi. This angle, which you,
Beta.
this is TL, right? Right? TL. This is your top view, right? Then even in front view, this angle is angle alpha, right? And then even though you can have measurement of end projected distance, you can extend it further either down or upward or downward. These projectors and this projector, this distance will be the distance between projector passing through A dash A and B dash B is going to give the end projected distance. Okay. Even though I will write the data here, this distance is nothing but 10 millimeter. This distance is 10 millimeter. Okay. Now this is the complete solution, right? Now let me know the values answer which you are getting. How much is this phi? Hello, measure it and let me know. Phi, alpha, beta, and PL and end projected distance. This 1, 2, 3, 4, 5. 5 unknown. Let me know your results, your values. How much? Yes, this 5. How much you are getting? 5?
28 degrees.
28 or maybe
No,
around
sorry,
28
sorry,
points.
sorry.
I will write it as 30 degree. Okay. Suppose 30 degree. Okay. Plus or minus 1 degree. Okay. Then alpha.
So it's not 28, it's more than that.
Okay. So I have written 30. Okay. See. Then what's about the alpha? This angle. TV? Angle with front view.
45.
Say 45. Okay. Then what's about the beta? Maybe 50 or something.
Sir, it's
Beta 50.
57.
No, I think not 57. Maybe 52, 53 something. See, the previous questions, whatever the result I got, on that basis, this question is designed. True length not change, angle not change with the front view. Even though EL, which you got in previous case, 43, I just rounded it. Maybe you will get might be a 47 something, 45. I will write 55 degree, 55 or 56 degree, right? I think that will be fine. Okay, 55. Then PL, you might be getting 55, 54. How much is PL? Maybe 50 PL, please. Otherwise, I will check it from my
53.
53.
53.
yeah. So I am getting it 52. I will write 52 here. Then end projector distance. How much? 25 point something?
Yes, sir, 25.
25. So in getting the solution for any question on projection line, you need not write the problem statement as a part of your answer. Directly you start with the given data. Read the problem properly, write given data, get the solution. Once your solution is complete, whatever the unknown parameters are there, you write down the values for that. Okay, and this will give the perfect impression on the evaluator. So there will not be any chance, if your answer is correct, there will not be any chance to lose even a single mark. Okay, so this way you have to conclude with your answer. Okay, this is the standard way to showcase your answer, to present your answer.